Okay, in this video we're going to solve problem 2.11 out of Griffiths Electrodynamics. It says uses Gauss law to find the electric field inside and outside a spherical shell of radius r that carries a uniform surface charge density sigma. Okay, now before I actually solve this problem, if you wouldn't mind please liking this video and subscribing, I'd really appreciate it. Alright, so we have a shell, so there's nothing on the inside here, right, of radius r, and on the surface here it carries some surface charge density sigma, and we want to use Gauss's law to find the electric field inside and outside. So let's start with the inside. R less than big R. So we have Gauss's law. And this is actually super easy because what charge is inside? And the answer is there is none. There's charge on the surface, smeared on the surface of the sphere, but there's no actual charge inside the sphere when you're looking at a radius less than big R. So the enclosed charge is just 0. This means that your electric field equals 0 for R less than big R. I'm going to just draw a little Gaussian surface here. That's for my, we'll do it in that color. Now, for R greater than big R, this one's a little trickier to draw, but I'm going to just draw a Gaussian surface here that has a greater radius than the actual sphere we're interested in. Maybe I'll just stick with purple. I kind of like that color. So once again, we can use Gauss's law here. And once again, we should ask ourselves, what is the enclosed charge? Well, we're outside the sphere, so there is charge on the surface. How can we find that? Well, sigma is your charge per area. So if you multiply that by the area, you'll just get charge, just through looking at the units. And the surface area for a sphere is 4 pi r squared. Pretty easy. Now if we look at our Gaussian surface, it's just a sphere, just like the real object we have, that purple sphere. So then we have our electric field times 4 pi little r squared. We're using the little r here because that's the radius of our Gaussian surface. I sometimes remember getting confused about little r and big R with some problems when I did undergrad EM. So hopefully that isn't confusing for you. Our enclosed charge is 4 pi r squared sigma, and then don't forget about the epsilon naught in our equation. This is pretty straightforward. We can divide out the 4 pi, no problem. And then I guess I'll finish this in white. We have r squared sigma divided by epsilon naught r squared in the r hat direction. And that's your electric field outside. Hopefully that all makes sense, and if it did, please consider leaving a like and subscribing. Thank you.